All right, this is the practice that had side angle side and side 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 on one side, and then angle side angle and angle angle side proofs on the back. So I'm going to zoom in so we can see this better. We'll go through these 12 proofs. Okay. So the first one here, we want to complete our proof. So we'll look at our statements and reasons here. First statement, first reason is always given. So what we're given here is coming from the diagram. So we have SR is congruent to TQ. Okay, and we also have that ST is congruent to RQ. Okay, so we have two pair of sides. We go down our list. We don't have vertical angles, but we do have shared sides. The side that's being shared is SQ. So we know that SQ is congruent to SQ by the reflexive property. SQ in the top triangle is the same as SQ in the bottom triangle because it's the same line. Okay, then we put our 3 hash marks there. Okay, so now we want to show that triangles are congruent. So we can use, we have 1 pair, 2 pair, 3 pair of sides. So we can use side, 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 show that triangle QRS is congruent to triangle STQ. And we're done. On to number 2. So first step is you're given. Okay, we're given that W is the midpoint of UV. You write this. W is the midpoint of the other thing from the diagram, right, because this is a right angle, we know that TW is perpendicular with UV. So let's go down our list. We don't have vertical angles, but we do have a shared side. So let's start there. TW is our shared side, so TW is congruent to TW. TW in one triangle is the same as TW in the other. Okay, that's your reflexive property. Okay. We keep going down the list. Next is midpoint. We do have a midpoint. So the midpoint's W is the midpoint of UV, so it's going to cut it in half. 2 equal pieces, so we know UW is going to be congruent to VW. Okay, that's your definition of a midpoint. Keep going down our list. We don't have parallel bisector, we don't have parallel lines, but we do have perpendicular lines. Okay, perpendicular lines form right angles, so we know angle TWV and angle TWU are right angles. And that's the definition of perpendicular. Perpendicular lines are 2 lines that intersect and form right angles. Since we have right angles, we can use the right angle theorem that says that all right angles are congruent. So since these are both right angles, we know angle TWV is congruent to angle TWU because right angles are congruent. Okay. We now have 2 pair of sides and 1 pair of angles, so we have side, angle, side. That'll tell us our triangles are congruent. So that's going to tell us that triangle TUW is congruent to triangle TVW. That's number 2. Number 3. our statements and our reasons. So one is given. K is the midpoint of ij. Okay, we're also given that IH is congruent to JH. Okay, we go down our list. We don't have vertical angles. We do have a shared side though. The side that's being shared by both triangles is HK. So we know that HK is congruent to HK. Okay, that's a reflexive property. Okay, fill it in. Keep going down our list. We have a midpoint. Yes, we do. We know a midpoint splits things into two equal pieces. So if K is the midpoint of IJ, we know IK is congruent to KJ. That's your definition of a midpoint. We now have three pair of sides that are congruent. So we can use side, side, side to show that triangle HIK is congruent to triangle HJK. And we're good for number 3. Head over to number 4. Okay. We have statements and reason. So statement number 1 here is your given. So we're given that K is the midpoint of GI. We also know that K is the midpoint of HJ. Okay, and it's given to us that HI is congruent to GJ. And 3 givens there. So we go down our list. We'd have vertical angles first. But let's use our midpoints. Okay, so we have a midpoint here. Okay, and here. So if K is the midpoint of GI, then we know IK is congruent to KJ. KG, I'm sorry. If K is the midpoint of HJ, then we know HK is congruent to KJ. Okay. And those would be definition of midpoint. So for 2 and 3, we'd have definition midpoint. You could have done that in one step. Would have been fine. Okay. But we now have 3 pair of congruent sides. Since we have 3 pair of congruent sides, we know the triangles are congruent. So triangle HIK is congruent to triangle JGK. And we're good. Okay, down to the next one. So we have statements and we have reasons. First statement is always your given. Okay, what we're given here is that FG is parallel to HI, and that HI is congruent to FG. So HI is congruent to FG, and then we know FG is also parallel to HI. So first thing on the list is vertical angles. We don't have them. Next thing is shared sides. We do have shared sides. So the side being shared is FH. So we know FH is congruent to FH by the reflexive property. We keep going down the list. We don't have a midpoint. We don't have a bisector, but we do have parallel lines. If you have parallel lines, we're looking for alternate interior angles. So here's our alternate interior angles. So we know that angle IHF is going to be congruent to angle GFH. Okay, those are alternate interior angles. So by the alternate interior angle theorem, if alternate interior angles are, if the lines are parallel, then your alternate interior angles are congruent. We then have side angle side, which tells us triangle FGH is congruent to triangle HIF. Statements, reasons here. Okay, so here's our given, which is the first step of any proof. So we know that GJ bisects at angle HGI. Okay. We also, from our diagram, know that HG is congruent to IG. Okay. So if we go down our list, we don't have vertical angles. We do have shared sides, though. So we can use the reflexive property, okay, to say that JG is congruent to JG. Then we keep going down the list. We don't have a midpoint. We do have a bisector. So bisector splits things in half. So we're bisecting angle HGI, which means we're splitting it in half. So into two congruent angles. So that means angle HGJ is going to be congruent to angle IGJ. Okay, and that's your definition of a bisector. It's an angle bisector. And then we have side angle side. Side angle side will tell us triangle GHJ is congruent to triangle GIJ. There you go for that. Okay. Now, if we flip it over, we'll be on the angle side angle part and the angle side. We've got 6 more to go. Some statements, reasons. First one is always your given. So what we're given here is that TQ is congruent to TP. Okay, we're also given that angle RQT and angle SPT are right angles. Well, I guess it's really telling us that they're perpendicular. Okay, so what this is really, the right angle is really telling us is that RQ is perpendicular to QS, right? And SP is perpendicular to RP. Okay. So we go down our list. First is vertical angles, and we do have vertical angles, so we use the vertical angle theorem. Okay. So our angle STP is congruent to angle RTQ. Okay, these are vertical angles. Okay, since we have perpendicular lines, that means we have right angles. So we know angle RQT and angle SPT are right angles. Okay, that's the definition of perpendicular. Since we have perpendicular lines, we know that we have right angles. If you would have written that this was your given, that would have been fine. Okay. We only have two pieces of information here, right? We have one pair of sides, one pair of angles, so we need to keep going down the list. We don't have shared sides, we don't have a midpoint, we don't have bisector, parallel lines. We use the perpendicular lines. We can now use the right angle theorem, right? That says the right angles are congruent, so we know angle RQT is congruent to angle SPT by the right angle theorem, which says right angles are congruent. We now have two pair of angles that are congruent, so we can use angle side angle to show that our triangles are congruent. So triangle PST is congruent to triangle QRT. Okay. Let's go down to the second one on this side. So we have our statements and we have our reasons. The reasons are always starting at the given. Okay, so we're given two things here. UW bisects angle VUX. We also know that UW bisects angle VWX. Okay. Go down our list. We don't have vertical angles, but we do have a shared side. So UW is congruent to UW by the reflexive property. Okay, we keep going down the list. We don't have midpoints. We do have bisectors. We have two bisectors. UW bisects VUX, this angle here. So that means these two are going to be congruent. And UW also bisects VWX, which means that these two are going to be congruent, right? A bisector splits it in half. So it's going to split VUX in half. It's going to split VWX in half. So for step 3 here, you can do this as 2 steps or just one. We know that angle XUW is congruent to angle VUW. And we know that angle XWU is congruent to angle VWU. Okay, and that's the definition of a bisector. It cuts it in half into 2 equal pieces. So we cut the big angles into the equal smaller angles. We now have angle side angle. Which will tell us their triangles are congruent. So triangle UVW is congruent to triangle UXW. Okay. Next one. Okay, statements, reasons. Okay, we start with our given. Okay, so we're given that angle T is congruent to angle R. And we're given that US is congruent to VS. Okay, we go down our list. First thing on the list is vertical angles. And look, we have vertical angles. So we know angle TSU is congruent to angle RSV. And that's the vertical angle theorem, which says all vertical angles are congruent. Okay, we now have two pair of angles, one pair of sides. The pair of sides is not included because it's not between. So we have angle, angle, side. So we use angle, angle, side postulate to tell us our triangles are congruent. Triangle STU is congruent to triangle SRU. Pretty simple there. Let's go up to the fourth one here. Things get a little more complicated on this side of the paper. Okay, so we have statements and we have reasons. First statement is always what is given. Okay, so we have angle UWV is congruent to angle TWX. So let's mark that. UWV is congruent to TWX. Okay, we also know that WX is perpendicular to TX, and VW is perpendicular to UV, and we know that UV is congruent to TX. Okay, so we can mark that. We go down our list, we don't have vertical angles, we don't have shared sides, we don't have a midpoint, we don't have a bisector, we don't have parallel lines, but we do have perpendicular lines. So what do perpendicular lines do? They tell us we have right angles. So WX is perpendicular to TX, that tells us we have a right angle here. So angle TXW, okay, is a right angle. Okay, we also have perpendicular lines here. So VW is perpendicular to UV. That tells us we have a right angle here. So that's angle UVW is a right angle. Okay, and that's your definition of perpendicular. Perpendicular lines are lines that intersect and form a right angle. Four right angles. Now, we still only have two congruent statements. We need a third. We can't use the third angle theorem. We can use the right angle theorem, though. And the right angle theorem tells us right angles are congruent. So the right angle theorem tells us all right angles are congruent. So we can say angle TXW is congruent to angle UVW because they're both right angles. We now have two pair of angles that are congruent, one pair of sides. So we can conclude that the triangles are congruent. Okay, by angle, angle, side, right? Angle, angle, side. It's not included. The side's not included, so it's angle, angle, side. Okay. Next one. Okay, so statements, reasons. Start with our given. Okay, so Y is the midpoint of UW. Okay, the other thing that given is angle UW and angle U are right angles. Okay. So we go down our list, vertical angles is the first thing, and we do have vertical angles here. So we can say angle VYW is congruent to angle XYU. Okay, and that's the vertical angle theorem. We know vertical angles are congruent. We keep going down our list. We don't have shared sides. We do have a midpoint. Okay, midpoint splits it in half. So Y is the midpoint of UW, We know that WY is going to be congruent to UY. Okay. And that's the definition of a midpoint. It cuts it in. Keep going down our list. We don't have parallel lines. We have, well, we kind of have perpendicular lines, but that tells us we have right angles. But the idea here is we can now use the right angle theorem. So we're going to use the right angle theorem. We have we have one pair of right angles, so we know those angles are congruent because the right angle theorem tells us right angles are congruent. Okay, we can then use angle, side, angle. Right, the side is between the two pair of angles. Angle, side, angle. So we can use that to show that triangle VWY is congruent to triangle XY. What's the time? 26 minutes? Sorry. Okay, and then the last one. Looks like it's fun. So statements and reasons. Okay, first up is always you're given. Okay, so we're given two things actually. We're given that VU is parallel to WX, and we're given that VW is parallel to UX. Okay. So let's go down our list. The first thing on our list is vertical angles. We don't have them. Second thing is shared side, and we do have it. So we know UW is congruent to UW by the reflexive property. We don't have midpoint, we don't have a bisector, but we do have parallel lines. So since VU is parallel to WX, we know our alternate interior angles are congruent. So angle VUW is going to be congruent to angle XWU. Okay, and that's the alternate interior angle theorem. Alternate interior angles are congruent. We also know that XU, or UX, is parallel to VW. So we know these alternate interior angles are going to be congruent. So we know angle VWU is congruent to angle XUW. And that's also by the alternate interior angle theorem. Since the lines are parallel, alternate interior angles are congruent. Okay, you could have done this in one step. That's fine. Either way. It's a preference, stylistic preference. We now have angle, side, angle, which tells us our triangles are congruent. Triangle UVW is congruent to triangle WXU. So there you go. That would be the 6 side, angle, side ones, and then back the 6 angle, side, angle, and angle, side.